Hello, welcome to Chapter 6.2 from Stevens' Introduction to Statistics, the Think and Do book. In this chapter, we're going to discuss normal distributions in general. In the last chapter, we talked about the standard normal distribution. And there was a particular type of normal distribution where the mean was 0 and the standard deviation was 1. In practice, though, we will be dealing with general normal distributions that have a different mean and a different standard deviation. But we don't have tables for every possible normal distribution, so what we do is we convert from, say, some normal distribution with variable x into the standard normal distribution with the variable z. And we go back and forth through these formulas in 6.3. So what this first one says is that if you have just some normal distribution with a given mean and a given standard deviation, then an x value from that normal distribution is converted into a z value by this formula. Right? So this basically, if you have x, gets you z. Now if you solve this same equation for x, you actually get this version of the formula. Basically it says if you have z and a mean and a standard deviation, you can get x with this second formula. But they really are the same equation, just rearranged. Okay, so let's get started. And to get started, I'm going to put us into full screen mode. There we go. Normal distributions in general. Okay, so here's an example, and it's an example we'll be using throughout this section. Suppose adults have IQ scores that are normally distributed, and the mean of these IQs is 100, and the standard deviation is 15. And the mean here we represent with mu, so that equals 100, and the standard deviation denoted with sigma is 15. Right? So we have a normal distribution, but the mean is not 0 and the standard deviation is not 1, so I can't immediately use the standard normal table from the back of the book. But here's the two types of questions we'll be asking. Suppose, in the first case, I want to find a probability that a randomly selected adult has an IQ which is less than 125. So I'm giving you an X score, which is an IQ score of 125, and I want you to find the probability that you get an IQ score below that. The second type of question is like this. You want to find the IQ score which separates the bottom 80% from the top of from the top 20%, and we denoted that with p sub 80. So in this case, we're looking for an actual IQ score and not a probability. We're given a probability right here. So we're sort of going back and forth between values, x values, or IQs in this case, and probabilities. So let's take a look at this first one, right? We have a question here. Find the probability that a randomly selected adult has an IQ score which is less than 125. And we know that these IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So here's how we go about solving this problem. Here, x represents IQ scores. So I'll even denote that. I'll even put little equals. Those are IQ scores, right? And notice the mean is 100. And we also put in the z axis. It's good to have two axes here because one will be for the IQs and the other will be for the z-score. So if I want to convert x equals 125 to a z-score, because look, the probability we seek, this is the probability. That's the probability of selecting someone with an IQ score of 125 or less. Right? But I can't look up 125 in the z-table because that's a z-score, and I have to convert this 125 into a z-score. So I'm going to use the first of these formulas up here, this one. I have x, mu, and sigma, and I'm going to get z. So when I do that, x is 125, mu is 100, sigma is 15. So I plug that into this formula. I get 125 minus 100 over 15, which gives me 1.67. So the z-score that corresponds to 125 is 1.67. Basically, all that says is that 125 is 1.67 standard deviations above the mean, which we have done in previous chapters. Right, so that formula for the z-score should be somewhat familiar. Okay, so now we have a z-score, and we can get the probability that z is less than 1.67 from the table. And that's going to give us the same probability that x, the IQ, is less than 125. So let's look up 1.67 in the z table. Go to here. It's a positive, so I need the next one. Don't get dizzy here. I'm looking for 1.67. So there's the 1.6, and then 0.7. So I'm in this row, in this column, 0.9525. So that's my probability, right? 0.9525. Right? So that's this area right here, 0.9525. And that's the probability we seek. Right? Basically what that says is that about 95% of us have an IQ below 125. Okay, so that's a problem of given an IQ score, find a probability. Here we're going to give a probability and look for an IQ score. So what we're looking for here is p sub 80. Right? We're looking for the IQ score that separates the lowest 80% from the top 20%. Right? So what we're looking for here is this value. Right? Remember, because x is IQ. Right? So what we do here, like we did in the last chapter, we look for 0.80 inside the z table. Right? Inside the z table. Right, and when you see inside in all capitals, that means you look for it actually in the interior of the table. Let's go back to our tables here. We're looking for 0.80. We know this is going to be a positive z-score because it's greater than 0.5. So let's look around here. What do we see? We have sort of straddled by these two numbers, right? We're looking for 0.80 inside the table. When I say inside, I mean in here somewhere. So we found two values, 0.7995 and 0.8023, and 0.80 somewhere in between there. This one, the 0.7995, is the closer of the two. So, what does that correspond to as a z-value? Well, it starts off 0.8, and the second decimal is 4, so it's 0.84. 0.84. That's the z-value. And that's sort of what we're looking for, but not quite. Right? So the 0.84 is the z-value. That's why I put this axis down here. And so now, by drawing these two axes, you can sort of see what we're trying to do with the formula. We're going to use the second formula in the above equations, where x equals mu plus z times sigma. But all we're saying is that this x value we're looking for, this question mark, is 0.84 standard deviations above the mean. So we take the mean and we add 0.84 standard deviations to it, and we get 112.6. Right? So the IQ that we seek is 112.6. That's this 112.6. That separates the lower 80% from the top 20%. It basically means that about 80% of us have an IQ below 112.6. Alright, so those are the two types of problems. In the first problem, you're given a value and you have to find the probability. In the second type of problem, you're given a probability and you have to find the value. Okay, so let's move on to the your turn problems. And we're going to stick with the IQ demonstration, because they're easy numbers, right? Mean of 100, mu equals 100, and a standard deviation of 15. Right? sigma equals 15. Let's do this first one. Find the probability that a randomly selected adult has an IQ between 75 and 125. Right, so what we're looking for in terms of area under a curve is this area here. Because if you look at the x-axis, and those are IQs, the mean is 100. I'm looking for the probability of randomly selecting a person with an IQ between 75 and 125. So that's this shaded area right here. So that's what I'm looking for. And notice it's an interior region, right? So what that means is we're going to be dealing with some subtraction. Right, we're going to find the area to the left of the bigger number and subtract from that the area to the left of the smaller number. But first we have to convert these IQ scores to z-scores. So when x is 75, I'm using the formula z equals x minus mu over sigma here. And I get x is 75, mu is 100, sigma is 15. I plug that into my calculator, I get a z-score of negative 1.67. So this is actually negative 1.67 right there. Likewise, when you do that to the positive 125, we get a z-score of 1.67 to positive. So this is actually 1.67. And it should stand to reason that those are opposites of each other, right? Negative and positive. Because what I've done from the mean here with IQs is I've gone down 25 and I've gone up 25. So it's going in the same distance in the two different directions away from 100. And so when you convert that to 0, which is the mean of the z-score, I get a negative value and a positive value of the same number. Okay, so now I have to find this area, right? I have my z-scores. And the probability that x is between 75 and 125 is the same as the probability that z is between negative 1.67 and 1.67. So the way I do this is I first find the area to the left of the bigger number. So when I look up 1.67 in the table, it's a positive z-score. Let me erase this. I'm looking for 1.67. There's my 1.6, right? And then 7 is this column at 0.9525. So that 0.9525 right here is the probability that z is to the left of the bigger number, right? Now I have to subtract the probability that z is to the left of the smaller number. Right? So when I look up negative 1.67, and now I have to go to my negative z table. Scrolling, don't get dizzy. I'm looking for negative 1.67. So that gives me 0.0475. So that's the smaller area. 0.475. And when I subtract the smaller one from the larger one, I get 0.9050. Right? So this area, which represents the probability we seek, is 0.9050. Right? So that basically says about 90% of us have an IQ between 75 and 125. Right? Going in the opposite direction, it looks like a similar question, but it's actually quite different. Find the range of IQ scores which define the middle 50% of adults. In other words, I need to find p sub 25 and p sub 75, because this area is going to be 0.25. There's the middle 50%. And then there's going to be 0.25 up in this tail too. So this is actually p sub 25, and this is p sub 75. So that's what I'm looking for. Those two question marks. And we'll get rid of these just for now. Okay, so to find this one, to find the first one, this one here, I know that 0.25 lies to the left of that value. So I'm going to look for 0.25 inside the z table. Right, so let's go to our z table, and I can tell it's a negative value because it's below the mean. So let's go to the, I'm on the negatives, good. And I'm looking for 0.25 0.25 inside this table. And again, when you see all capitals inside, it means in here. Alright, so looking for 0.25. Things are getting bigger, bigger, bigger. Looks like I'm getting there. Looks like these two here straddle it. Right? And again, it's seldom that you'll actually find the number you're looking for, so you look for the closest one. And 0.2514 is actually the closest. But that's not what I was looking for. I was actually looking for a z-score. So I found the proper probability, but now that corresponds to a z-score of negative 0.6. And then we have to find out what column this is. 7. So z is negative 0.67. So that's the z-score I'm looking for. Z is negative 0.67. Now if you want this other one, you have to notice that there's actually 75% to the left of that value. So we look for 0.75 inside the z table. And you can look for that, but there's actually sort of an easy way around this. We know that this one is negative 0.67. I'm looking for the middle 50%, so whatever I go down by, as far as distance goes that way, I should go up. So I'm guessing I'm going to get a 0.67 here. Alright, because it is symmetric. Okay, so, but if you do look for 0.75 inside the z table, let's see what we get. Inside the z table, I know it's a positive z-score. I'm looking for 0.75. So let me erase this from the last problem. So in here, I'm looking for 0.75 inside. Right. Okay, so where are we? Looks like we're at the top here. 0.742 points. Here they go. Here we go. Right here. 0.7486 and 0.7517. And again, 0.75 is not in there, but this one is closer. 0.7486. But again, we weren't looking for that. We're actually looking for the z value. And the z value starts with 0.67. So the z equals 0.67. Alright, so let's go back to our problem here. 0.67. So that's what we just found. And our guess was correct, right? So now we have to convert these to IQs. Like we have the z's down here, but what I want are these IQs up here. And basically what it says is that this one here is 1.67, or sorry, just 0.67 standard deviations below the mean. In other words, I take the mean and I subtract 0.67 standard deviations. Gives me 0.8995. And this comes from that second formula, which looked like this. Oh no, it didn't start with z, it had x. It said x equals mu plus z times sigma. Right? And so that's what this is right here. Right? It's just this second. I'm going to scroll here quickly so don't get dizzy. I'm using this formula right here. Okay, so, and again, if you draw both of these axes, you don't even really have to memorize the formula because it's basically telling you 6.7 standard deviations below the mean. And when I do that, I get 89.95, so that's what this one is. 89.95. And then the next one, the higher one, is 0.67 standard deviations above the mean. So I take 100 plus 0.67 times the standard deviation, and I get 110.05. So that's the IQ I'm looking for. That's 110.05. Right? And so that's what we wanted. The middle 50% of us have an IQ between 89.95 and 110.05. Right? So let's move on to your turn number 2. In this case, you are a manufacturer of ice cream that you sell by the pint. And the weights of this is chocolate chunk apparently. They're normally distributed, and the mean is 408, a standard deviation of 4.5 grams, right? So that means we have mu equals 408, and sigma is 4.5. And basically, I want to sell the lightest 5% at a reduced rate, or a discount rate, right? Don't want any angry customers. So the question is, what weight should be used as the cutoff? What determines the lightest 5%? So we draw our normal curve, right? Any variation, it doesn't have to be perfect, just has to look sort of bell-shaped and symmetric. And so what we're looking for, we know that for our x value, which is the weights of ice cream, the mean is 408, and I want the value that separates the lowest 5%, 0.05, from the rest. Right? So what I need to do here is I'm going to look for 0.05 inside the z table. Right? And so when I do that, I know I'm going to be at a negative value because it's well below the mean. So I'm looking for 0.05. Let me erase some of this stuff. Okay. I'm looking for 0.05 inside the z table, right? 0.05 inside. And as you search and scan and look around, what you find is an unusual situation here, where you have 0.0505 and 0.0495, and 0.05 is right in the middle, right? So neither one is actually closest, but what you should also notice is that there's a little dot right there. That's sort of the dot you're looking for. And if you scroll down, here's that dot, right? Has an area to the left of 0.05, but more importantly, the z-score you're looking for is negative 1.645. And that should make sense because if you look where this thing resides, it's negative 1.6, and it's between 4 and 5. So the z-score we're looking for is negative 1.645. Right? So let's go back to our problem now that we have our z-score. So we have negative 1.645, but that's not a ice cream weight. That's a z-score. So what this is telling us with the two-axis system is that the question mark, this thing I'm looking for here, is 1.645 standard deviations below the mean. Or according to our formula, x equals mu plus z times sigma. But z in this case is a negative. So we can just write mu minus 1.645 times sigma. And we get 400.6. So what that tells us is that this question mark here, the cutoff weight is 400.6. So you should sell all pints that come in under 400.6 at a reduced rate. And if you choose that as the cutoff, you shouldn't sell more than 5%. You should sell about 5% at a discount rate. Right? So you're not going to sell too much, but about 5%. Alright, so that wraps up chapter 6.2. And we will go on to 6.3, which is a short section, and then 6.4. Okay, bye.